So, hello candidates, very good evening to everyone. Okay, I hope everyone is doing well, right? Let me just share my screen. Can anyone let me know am I audible or not? And I have shared my screen, just also confirm this one. So my screen is visible or not, right? Hi, Sarath, Spurti. Okay, got it. Hello, Tarun. Perfect. So class, I have already shared my screen. Now let's just directly come to the topic. So today we are going to start the implementation part of a convolutional neural network, right? Yesterday we completed multiple things. It was like a complete practical implementation of artificial neural network, right? And we have also studied the same thing related to the convolutional world, right? So we are going to start the convolution part. So CNN complete practical. Okay. So let's just write this. Okay, now we know that CNN is just the combination of convolution. So let me just write this. It's like a convolution. VOLUTIONL, convolutional neural network. Perfect. And we know that the convolution is just nothing. It's like a set of mathematical process or like operation we generally perform on set of image processing or like any sort of image data set. Okay. So whenever we are getting the image data set, okay, now let me just very clear. If we have to predict the regression problem, if we are into the regression problem, we have to predict the sales value or like the numerical value. And if it is the values are like in continuous or like numerical in nature, so you can use the ANN. ANN is like the artificial neural network, right? Now, when it comes to image processing, kind of, okay, if you have an image data set, audio, not the audio one, video data set, right? Then you generally use the convolution part, right? So once you are familiar with this convolutional neural network, now, then you can do multiple things, right? The first thing that you can do is called the image classification, okay, where you can classify the multiple images, whether the given images is like a cat, dog, truck, driver, car, aeroplane, any sort of image classification. You can do this with the help of CNN, like the convolutional neural network, right? But when it comes to image partner, so we have multiple things in the image. And let me just show this image, right? We have a classification plus localization. The second problem we generally tackle in the image classification, like the image data set, is like the object detection. Okay, I hope everyone has seen this kind of images where we need to draw this bounding boxes. This is called the like the boundary boxes. You have to design all these bounding boxes, right? So let me just show this image bounding boxes. And the person that generally do all this task is called the annotation engineer, or not the annotation engineer. That person is an annotation kind of person that generally try to pick the values or just try to pick the images, and they need to draw the bounding boxes. Okay, this can be done with the help of a software or with the help of manual like Paint as well. Okay, you can just simply call the image, open the image. You just need to draw the bounding boxes, right? So the first problem we generally tackle in the image is like the image localization classification. The second one is called the object detection, when you just need to detect the objects, right? Different objects. The third thing that you need to perform is called the segmentation, and that is called instance segmentation. What is instance? Instance is like the particular image that you are looking for. Okay, if you are looking for a kind of subject, like this is a subject, this is a dog, cat, like this one is also a dog, this one is a cat. So you are just subjecting that boundary. This is called a segmentation, instance segmentation. And third one is called the semantic segmentation, where you will identify the objects and you will fill out with the colors. Like this is the grass area, this is the cat area, this one is the sky, this one is the tree as well. So you will perform all this set of segmentation. So whenever anyone is talking about like they are working on this field of image classification, segmentation, so we have to understand this four set of differentiation, right? So if you want to perform all these things, now you have to be very familiar with this CNN part. And CNN is just nothing, it's a convolutional neural network. So whenever you are getting the image data set or like the video data set, you have to perform this operation, right? Now, what about the convolution one? So we already knew that convolution is just like a mathematical procedure or like a process that generally designed to filter out the pixel data of the given data set or like of the given images. Okay, if you have this image, you will just move your kernel in a forward or like in a backward direction. You will try to pick out the pixel value, and you will perform some sort of matrix multiplication with the pixel value or with the pixel array that you are calling, and that procedure is called the convolution part. Okay, so let me just show this convolution math. So the math behind is something this. You will simply call your pixel, okay, like this one. This is the input like array that you are getting. You will design or you will decide this kernel filter. This kernel filter is like the by default set of weights, and it has been generally like initialized by the model or like by the system itself, right? Then you will perform the the matrix multiplication, and you have to summing up all the values, and finally you will get the output, right? Here you are just getting the answer like this: 775748629 is the pixel of input. This is the kernel filter that has been decided by the model itself, and you are performing the convolution product. And once you're performing, you're just summing up all the value, and with the particular picking up this array, you are just summing up all the value and you are finalizing the output, right? And this step is called the convolution part. You have to perform this convolution part. If you just like scan this images multiple times, you will perform this convolution part multiple times. Once you perform this convolution part, then you have to max pull your data so that you will not focus on all the convolution array. You will just simply focus on the required array, and that is called the max pulling part or like the average pulling part. So max pulling and the average pulling is like you are just preferring the maximum value of the given set of array. If this is the array, if this is the input, this is not the actual input, this is the convolutional input. You will just pick out the maximum value of the given kernel size array, right? The kernel that we are taking right now is 2 by 2. So you will just simply find out the maximum value of this array. It's like 8, this one is 6, here it is 9, and here it is 9. And you will just give the output as 8699. Now it's your particularly choice. You can again apply the convolution part over this output, and that is called again the convolution part. And again you will do the max pooling part, or you can perform the average pooling as well. Instead of max pooling, you are just simply taking the average, and we have already discussed this in the last class, right? Once you got all the max pooling or like the average value, then what you will do, because you know that this is the convolutional process, and generally interviewer asks you how to extract the features from the given set of images. So if you want to map your features, if you want to like extract your images features, you have to call this convolution part. Once you call this, this process is called the feature mapping or feature extraction. Now you have to flatten your array. So the flatten is like this is n-dimensional array. Why we are getting the n-dimensional? Because we are reiterating this images multiple times. Convolution 1, convolution 2, 3, 4, with different set of segmentation, right? So we will flatten this array into 1D array. And once we got the 1D or 2D array, then we can simply pass out this inside the neural network. And we are already aware with the artificial neural network. So in short, the CNN is just nothing. The first process is called the convolution part, where you can decide the input data, kernel filter, convolution step, max pooling step. You can reiterate this multiple times. You can decide this. This is also the part of dense layer neural network, right? Once you sort out this all convolution part, you will flatten your array. If you are not flattening your array, this will generally give you the errors, right? Once you flatten your array, then you can decide your ANN part, and you already aware with that. You can decide the multiple dense layer inside the ANN part as well, right? Once you take an input of the convolution array in the form of flattened layer, then you will decide the hidden layer, which is by default value of the neuron that you can generally pick. And then finally, you will decide the output neurons, and output neurons is generally decided based on the classification problem that we are performing on, right? If we are getting the multi-class classification, so we have to decide the neurons based on that, right? If the problem is related to the binary classification, so we will generally pick the one neuron at the output, right? Here we have to create a model that generally try to predict the three set of classification: red panda, panda, and the raccoon. That is the reason we are picking just 3 neuron at the output. And the activation function that we are using is the softmax activation function, and it is recommended if you are performing the multi-class classification, you have to use the softmax activation function. This is the set of generally based on the probabilistic theory, and you are just calculating the probability of the each class, and you are just representing the highest probability of the maximized one, and then you will predict the value whatever the maximum probability you are getting for, right? So this is all about for the convolution part. Let me just copy this image. Now we'll try to perform the practical aspect of this, right? So how to do this? we have to perform some sort of practical one with the help of coding part, right? So now let's just call one popular data set that is called the CIFAR dataset, right? This is very popular dataset. Let me just show this. CIFAR dataset is like, okay, let me just show you when this dataset was launched, okay? Launch date. See, machine learning, deep learning is not the popular concept, right? It is very old concept, but the problem is because of the trend. That is the reason everyone try to learn this concept. But the data set was popular around 2008 and it was published in 2009, right? So if you were particularly working at that time, so you can just say that, okay, this is not the new concept, right? So CIFAR is very popular data set. What exactly this data set is? This data set is a composition or composed of 60,000 images. Okay, I'll just again repeat, this is the collection of 60,000 images, and these images are very very popular images of the 10 different classes. Each classes you have some sort of 6,000 of images. 6,000 images for class airplane, 6,000 images for cars, 6,000 images for birds, cats, and followed by the rest of the classes that you have. Because this is the problem for the multi-class classification. Now, so can I just say at the output, what we want, we need to give the set of 10 neurons. Why? Because we have 10 classes at the output, right? So let me just show this image data set first. Then you will understand, right? These are the data set that we have inside the CIFAR data set, okay? So you will get the 10 different classes, and for each class, you have 6,000 of images. And these are the classes: airplane, automobile, bird, cat, deer, dog, frog, horse, ship, and truck. And you know that, candidate, if you're talking about the images, so images are just nothing. It's a array kind of thing, right? You can store any images in a sort of array format. So if we are calling this data set, if we are downloading this data set, na, so data set will be downloaded in a form of array, not in the form of images, right? You can convert that array in a form of images, and you are already aware with that, right? So let me just download this data set, then you can probably understand how to check the images as well, right? So what you have to do, you can just simply call the multiple modules, right? So let me just call the modules. Import step 1, import required modules. Okay, this data set has already uploaded on the open source, so you can simply download this one, right? REQUIRED, right? Import required modules. So you can just simply import TensorFlow. Okay, let me just first run this any code because I need to connect this with the Google server. So import TensorFlow as TF. Then you can call the REST modules from TensorFlow. Inside this, you have to call the Keras, and from TensorFlow.Keras, let me directly write this one. We have used this one, which is called the sequential. Why I'm not getting the suggestion? Sequential. Let me run this. Is there any error? No. Okay. So from TensorFlow dot, not with this Keras, we can call the data sets, right? You can call the data set as well. And what you want to import the CIFAR data set. Where's the CIFAR data set? You have to write this one. Let me just write this. Where's the CIFAR? You will get the hint, I think. Where's the CIFAR data sets? No, we are not getting the hint. So let me just write this as CIFAR. Just go to Google and take a hint from this. What exactly this data set is? CIFAR. Okay, it will give you the hint how to load this data set. Yes, you can write this one from sklearn.tensorflow.keras dataset CIFAR-10. Yes, so the name is like CIFAR-10. What you can do, you can just simply write this one, CIFAR-10. Okay, now you know that you can just simply call the layers as well. So from TensorFlow, let me just call the from TensorFlow, okay, and go to this Keras, and inside this Keras you will get the layers option, and you can import the like two different layers. The first one is called the dense layer, and second one is called the flatten layer. We have already used this in previous classes as well, right? Okay, now you can just call the layers as well from TensorFlow dot Keras, where you can simply call your like convolutional layer as well and the max pooling layer as well, right? So this is also the part of this layers, right? You can just call this one import convolution. You will get the hint here, right? This is the convolution 2D or 3D. You can just call, right? So let me just call directly here from TensorFlow dot Keras import layers and import matplotlib dot pyplot as plt, import numpy as np, import pandas as pd, and let me just call import os as well. Okay, and I think this is enough. Okay, if you want to create a set of like streaming model where that it can just take a live streaming of like images data set with the help of camera, so you can use the OpenCV module, right? So if you want to work this live, so you can use this OpenCV module, and for that you have to call this pip install OpenCV. And once you install this, then you can particularly pip install OpenCV Python. And once you install this, then you can call this module with the help of import CV2. Okay, now let me just run this as done, where all modules loaded successfully. So the problem is data. It's not data set, it's data sets. Okay, yes, it's done. So we have successfully imported all the modules. These are the modules that are required to particularly work on the convolution part. Okay, now let's just call this data set CIFAR-10, and we know that what exactly this data set. We have to load this data set. So just go to this, simply call this LOAD. You will get the option from here, right? CIFAR.load data. Just call this load data, and this will give you now a module object is not callable. So okay, this is not the module, right? This is the data set. So we are downloading this data set, right? It will take some time. So what I'll do, this data set requires some sort of internet, right? So what you can do, it will directly give you the xtrain, xtest, ytrain, and ytest data set. So you can just simply unpack this data set right here, xtrain, and no need to write the it's like train test split kind of thing, because this the structure is fixed here, right? So you can just call this xtrain and ytrain. This will give you in the format like this, xtrain and ytrain, and then again xtest and ytest. Okay, this is the by default format of this CIFAR data set. You can run this. Let me just stop this one, and let me just check the internet. Okay, and you can just call this one. It will take some time, candidate, because the data set is very huge. Now once you run this, so this is the data set. Let's just wait for that. Till now I'll just give you the overview of this one. Okay, so if someone wants to get into this like image processing, so they can use the OpenCV module. OpenCV is very popular one, right? Where you can draw the bounding boxes. You can particularly work on any sort of field, like where it is, whether it is image processing, object detection, like the geometrical or like video kind of analysis. I hope everyone has seen this kind of data set or like the images everywhere, which is like online e-challan kind of something, this, right? Where it will detect the speed of the vehicle and generate the challan based on that, right? So online like number plate detection. Okay, number plate detection. This is the like project you can particularly solve with this OpenCV module, right? So this is car 4, Toyota, car 3. For that you need to work on the OpenCV module, right? You can count the vehicles as well, right? This is very popular technique. See, if you are familiar with the deep learning, so you can decide your path, whether you want to go into the image processing or you want to go into the language processing. So if you want to go to the language processing, so what you can do, you have to work on the NLP technique, which is done with the help of a RNN. RNN is like the recurrent neural network. You have to understand the RNN concept very well. Then you have to focus on the NLP. Then you can particularly work on your small language model, which is in short term we call this as SLM, small language model. Then you need to understand the transformer architecture, right? Transformer architecture. Okay, TCTURE. Then you have to understand the self-attention mechanism. We have multiple things in this field, right? This is the further extension of the deep learning. Transformer architecture, self-attention mechanism, right? And then You have to use the GPT concept. GPT is like generative pre-trained transformer. It's completely based upon the transformer concept. Then you can plan with your LLM as well, right? LLM is like the large language model. Okay, large language models. Okay, so if you want to go in this field now, where you have to work on the text classification, like review sentiment analysis, or like a set of generative any textual to textual information. So this is the part of this NLP technique. NLP is just nothing in natural language processing, right? You have to deeply understand this RNN concept, right? Now if someone wants to get go into the image or like video kind of analysis, so they have to work on the OpenCV module. OpenCV, first it was written on the C++, then with the popularity of Python, now all the modules of OpenCV is available in the Python itself, right? So previously the companies were using the C++ to implement this kind of stuff, but right now they're using the Python. And if they want to build the software from scratch, so mostly they will use the C++ as well, right? But the popularity of AI increase the module structure in the Python. So that is the reason we are using the Python right now in the market. So if you further want to go into the image and the video processing, you can use the OpenCV as well, or the neural network required here is like the convolutional neural network. And obviously the CNN is also based on the ANN. So you have to first understand this ANN as well, right? Then you can use the another module that is called the YOLO module, right? YOLO is very popular one. Whatever the advanced streaming that you are particularly seeing in the market, or whatever walking in the market, is completely designed by the YOLO, right? So YOLO is like you only look once. Okay, so all advanced project has been done with the help of this YOLO, right? Even in the current scenario, like whatever the open source project, if you want to work on, so you can use this one, right? So let me just show you some advanced project of the YOLO, like object detector part one. You can do this, right? You can just simply go to the YOLO website, right? Just go to the YOLO website, and this will give you the Ultralytics YOLO documentation, and you can particularly pick any of the project, or you can call the GitHub repo, right? Just go to their like the models, and you can call all the models. These are the models of the YOLO, and it is further the extension of OpenCV, right? If you want to work on any set of like the segment analysis, all these are open source, right? You can call this. You can take a YouTube reference as well, right? So these are the projects that you can particularly build using this YOLO. Let me just show this. We have the like very popular project with the help of YOLO as well. So let me just show this, right? So you can just particularly go to the computer vision using the YOLO. Let me just go to this reference. You can check them, like these are the project that you can do with the YOLO, right? See, it's like the image segmentation kind of. We are just segmenting the images with the help of this YOLO modules, right? So you can perform all these things, right, with the help of YOLO one. So, and the best thing is that you required a lots of GPUs, right? But you can use the Google Colab, because this by default give you some sort of 120 plus of GBs RAM, where you can particularly fine tune on any of the models that available online, right? So guys, you can just call all the things, right? You can just take a reference of all this, like compare data set solutions that the YOLO is giving. You can just click on this and just look at this, right? These are the solutions that has been provided. See, YOLO is not like the set of companies that generally gives the solution. It also gives the models, right? You can call that model. These are the open source model. Okay, you have to use the API keys. These are the set of models. Now just look at this one, right? How popular this project is. You can just click on this and check the number of vehicles available in the parking, right? You can just take a reference of the images. You will draw the boundary boxes. It was like purposely done for the model training. Once the model is trained, then you can particularly check the number of occupancies and the availability of the parking, right? Just look at this, right? This can be done with the help of deep learning and with the help of YOLO modules, right? So these are like object counting, and it's practically using in the market right now. Okay, so there is one more popular company that is called Prisma.ai. Let me just show this. It's also doing the same thing. Prisma. Let me just write the Prisma.ai. I've seen this company recently in the AI summit that was held in the Delhi. So this company is also doing the same thing, right? With the help of object detection classification. So you can just check the image projects, right? So these are the particularly not this set of images, right? Let me just check the solutions provided by the Prisma.ai. You can just directly go to their website. This is the Prisma AI Global Pioneer, right? In this field, see, look at this, the solutions that they're providing, right? They're like particularly industry based. You can just check, right? These are the things, the car, like you are just particularly checking the object detection set of problem, right? You use this in industry, you can use this in like any sort of manufacturing industry where you need to check the like production per hour, like where you have to check the production of devices per hour. So you can use this, like you can use this in examination center and any sort of the problems whatever you can be handled with the help of image processing. So you can use this company's project as well. They will give you the API call as well, right? So these are particularly the set of things that you can particularly work on, right? So we have downloaded this data set. Now this data set is very huge, so let's just check this data set. So what you can do, you can just simply go to this xtrain.shape. So this is the 50,000 of the data set. Now why we are getting the 32, 32, 3? So 32 by 32 is the dimension and 3 is the channel, right? So you can just simply call any of the images and you can have a look of the data set that we have, right? So this is the 10,000 of the data set for the testing part, right? So once you combine the xtrain and the xtest, you will get the overall of 60,000 of the images. Now we know that because this is this project, so let me just copy this image and let me just paste it here because we have to build the project based on that, right? So these are the 10 different classes that we are getting the data set for, and each classes we have 6,000 of images, right? Now what we'll do, class we know that, right? Okay, let's just first check the image of any of the data, right? So you can just call xtrain, just call any array. This is the array, and see, it can be shown with the help of Google Colab, but you can show the data. This is the data, right? And if you want to show this data in sort of array, so you can just call this plt.imShow, where you just need to pass this data. And this is the frog image that we are getting, right? But we are not particularly it's not look liking the frog data set. So just do one thing, you can just call the plt.show and just simply call the plt.figure. It exactly not looks like a frog, right? So you can just call this plt.figure and just call this as a fig size. Let me just call the fig size. So what you can do, you can just simply give the dimension of this one, and now you can just simply say, okay, this is some sort of frog, right? So let's just try some with the random data. What about this data set? This is like the deer one. Okay, now what about this one? Okay, I think this is again the deer one, right? Let me just check this one. Okay, this is for the cat, I think, right? Let's just check the 800. This is some sort of bird, right? Yeah, this is the bird, right? So guys, you can just check now. We have some sort of different images, right? And now what we want to train our model based on the given data set. I hope everyone is getting my point, guys. Is there any doubt or any issue as of now? I don't think so, right? So let's just continue. So now we have 50,000 images for the training data set and 10,000 images for the testing data set. We are just looking some random data and we are just checking, okay, this is the data set that we have, and you can just have a look. If you don't want to show the like images, you can just check the shape of this one, and we are getting 32 by 32 by 3. And why we're getting the 3? Because this is like the RGB channel. Okay, now just look at this one thing. Once we are getting this data set now, so we have to understand the minimum value of this xtrain is like 0, and the maximum value of this xtrain is like the 255 pixel, and we know that the RGB channel like lies within a range of 0 to 255. So what we can do, candidate, we want to particularly scale out our feature between 0 and 1. So either you can use the min-max scaling, we know that we can use the min-max scaling, and you can use the standard scaling as well, right? ST, A and DRD standard scaling. So we have two different techniques. But what we can do, because we have this data in a form of array, so we can simply divide this array by 255, because the maximum pixel range is 255, right? If we divide this data set by 255, so what we will get? Either we will get the 0 divided by 255 is like the 0, and 0 divided by 2, like 255 divided by 255 is like 1. So we are just converting this data set of x and x test, train and test into the 0 and 1, so that we can call the data set. Okay, now let's just call this x train of scale data set. So we will write the variable name as SCA. SCA is like the scale. Let's just call this x train, and you can divide this data set by 255. Now just repeat the same step with the x test. X test, called this as SCA, and just simply pass this as x test by 255. Now we have simply converted our data with the set of like training and testing, like a 255 kind of thing, right? Now what we can do, we can just simply check the maximum part of this. So the maximum is something like this: x train SCA dot max. You will get the maximum value as 1, and same with the x train SCA dot max is like the 1. Okay, so now we have converted our data set into the set of training and testing part, and the data set is scaled, right? Okay, now we know that the data set has the 10 different set of classes. So you can just go to this, and you can just call the 10 different set of classes, right? So just wait for this. We have 10 different set of classes, where the first class is of automobile, right? So the not the automobile, it is like the airplane, automobile, bird, cat, deer, frog, horse, and ship. So what you can do, you can just simply write this thing. Okay, so the data, okay, let me just write this as CLA classes is equals to, we have 10 different classes now. So we can just call this, the first one is like the airplane. Okay, second one is like automobile, bird, and cat. So let's just call this. Second one is like automobile. Third one is the bird. Okay, let's just hit enter. Fourth one is cat. Fifth one is deer, dog, frog, and horse. Okay, so it's like the deer, and just simply write the dog, and then it was frog, and then the after the frog it is horse, ship, and truck. Okay, so let's just write this horse. Let's just hit enter, and the second last is ship, and the final is truck. Okay, so we have all the classes, and we have to predict the model based on the classes that we have, right? So these are the classes that we have with this data set, right? Now we know that we have already checked our data set. Okay, so let's just try to build the CNN model. Okay, now I'll give you one task, candidate. This is your homework. You have to create a same model of ANN to solve this problem. Okay, and then let me know what is the issue that you are facing. Okay, you know that the step is same. You can just call the model, give some like the data set, flat the data set, call the dense layer, pass some neurons, like neurons, and it will create a neural network. Then compile that model, or you can fit that model. Or let me just do one thing. Let me just show this, right, so that you can understand. Model ANN is equals to, you can call the sequential. Inside the sequential, you have to pass the list, and we know that because we are directly solving this with the help of ANN, without the CNN part. So you will get some error set off, right? So you have to first flatten your data, right? So you will call the first layer, which is the flatten layer, right? And after that, you have to decide your dense layer. Inside the dense, you can pick any of the random neurons, right? So let me start with the 100 one, right? Then you have to use the activation function. Activation function is like the ReLU that I am using. You can give the input shape. Now just look at this. Input shape is like something we have 32 by 32 by 3 now. So let's just check the any of the data set x train SCA dot shape. And once you call this, so you will get the 50,000 as well. So you don't need to call this, right? You can just simply slice out this value, and you just only need this one. So what I do, I'll just simply copy this one, and this is like my input shape. Okay, now you can just copy this one, and no need to copy. You can just call the another dense layer, where you can give the 100 or like 1,000 of neurons. You can just pass the activation function as like ReLU. And let's just finally call the last layer, which is like the output layer. And output, you know that because we have the multi-class, and the classes is like 10 in one. So you can just call the 10 layer. If you don't want to write it manually, so you can just copy this one. Okay. You can just copy this one, and you can call the length of the classes, right? You can call the length of the classes. Now let's just run this model. Let's just compile this model, model ANN dot compile. And for the compilation part, you have to call the optimization function. So let me just write this as optimizer. Optimizer, you can use the Adam optimizer, right? We have already used this. Okay, now what about the loss? So in the last class, we were using the binary cross entropy now because the classification was of the binary nature. So what you can do, you can just call this sparse categorical cross entropy, right? So let's just call this sparse. Sparse is for the multi-class classification, right? Categorical, CATEGORICL, sparse categorical cross entropy. Okay, this is the loss that we are using for the calculation part. And finally, you can write the matrices, not the metric, it is like the matrices. And matrices, you can use the ACCU. Matrices is equals to accuracy. And let's just compile this model, right? We have compiled this model. Okay, what is the issue? The spelling of the compile is wrong. CUMPILE, compile. Okay. Trainer compile got an unexpected matrices, spelling is wrong. METRIC matrix. Okay, not the matrices. Okay, now we have successfully compiled the model. So let's just try to fit this one, model ANN dot fit. And you know that for the fit, you have to give the X training data because we have scaled the data set. So we will give the scaled one and you have to decide the epochs. Well, the thing is that we don't want to solve with the help of ANNS. So let's just keep this for the 6 epochs or like 5 epochs so that you can just understand, okay, whether the accuracy is improving or not, right? So let's just check. If the accuracy will not improve now, that is the reason we have to check. We have to train our model for the CNN part 1, right? We are getting the accuracy. See, it is not the 97%. It is like 1% or like that. You can just say that if the value will become like this one, so it is like the 10%. Okay. So now just look at this. The accuracy is not improving that much and the loss is at very huge. So we are training this model for the 6 epochs using the ANN part, right? But we have to solve this model using the CNN. So once it is done, now let me just click on this. We will just parallelly write the solve using CNN because we have to solve this using CNN. Okay, it will take time. So parallelly, let's just write some code from sklearn, from TensorFlow, not sklearn, from TensorFlow dot Keras. From TensorFlow.Keras, go to layers and just look at this image. What we want, this is the input data set. The first thing that we want to call is the convolution part. Okay, so you have to call this inside this layer. You have to import and you have to import the convolution part. Okay, so the convolution part is something like conv2d. This is the convolution part that you have to use. And the second thing that you have to use is called the max pooling. Now, this is the max pooling, or you can use the average pooling as well. So let's just write this as max. Why we are not getting the hint, right? Max pull 2D. Okay. So let's just first run this. And if we get the done answer, so yes, it's working, right? So guys, now just look at this. The loss is instead of increasing, instead of decreasing, the loss is increasing, right? This is the problem with the ANN because the model is not able to optimize the data set and it's not perfectly understanding the data set. That is the reason we have to solve this set of problem using the CNN part. And the CNN is very easy, right? You can just take the input data set, do the convolution part, do the max pooling part, flatten your array, call the ANN part, and finally give the output neuron, and then it will predict the value, right? So let's just build the model for the CNN. So model, instead of ANN, let's just call the CNN. And what you can do, you can just simply call the sequential model, right? And you have to again create a list of things. Okay, now we know that the first thing that we have to do, this is the input, right? And we have to decide the convolution part. So what you can do, you can just call this convolution layer. And the convolution layer, you will just give this the number of layers that you want. Okay, So again, it is the set of neurons that you want to give. You can just simply start with this like shape of your data set. And the second that you have to give is called the filter size, right? The kernel size. So the kernel size generally be kept as like the 3 by 3. This is the kernel size, right? Let's just show where is the kernel size. This is the max pooling one. And yeah, this one is the kernel size. It's like the 3 by 3, we generally keep this one. Okay. Now you have to do some padding. Padding is like let's just increase. See, if we there might be chances we can skip like we might skip the corner pixel, so we will increase the padding size, or like we are just increasing the margin of the each corners element. That is called the padding. And at this padding we have to keep the value as same. Now just pass the activation function. Recommended is the ReLU. This is the convolution. Okay, this is the one convolution layer that we have performed. Now what about after the convolution? You have to decide the pooling part, and pooling is just nothing. You are just calling the maximum feature from the convolution layer, right? This is called the max pool. So you will just apply the comma, you will call the max pool data, okay, max pool 2D, and you have to give the filter size again. So in generally it is recommended as a 2 by 2, right? Like this one, okay? We are using the 2 by 2 filter for the max pooling. Now this is one convolution layer, right? The one convolution layer and followed by the max pooling layer. Now what you can do, you can just simply recall this convolution and max pooling to particularly train your model well, right? So let's just simply again, because this is the sequential now, so you are just calling the convolution, then you are performing the max pooling, again you are calling the convolution, you are performing the max pooling. If you want to increase the number of filters, so you can just increase the filter and to make it as 64. Now let's just again call the convolution, and why I'm doing this, to just let you know, it's not to just fix this convolution and pulling. We can increase the number of convolution and the pulling to just keep extract the features as much as possible, right? So you can just let's just keep this as again 64. Now this is the final convolution. Let's just keep this as half of this 64. Okay, we are using the ReLU activation function multiple times. Now you know that the final pooling we have performed, and after the final pooling we have to flatten your layer. So what you can do, you can just simply call the flatten method. This flatten method will flatten your layer, and then finally you can call your ANN, and the ANN is like the artificial neural network. After the flatten, either you can paste this one, right? After the flatten you can paste this one, because we have mostly performed this using the convolution partner. If you want to do this, so let's just paste this one, right? This is the ANN part that we are using. So let's just paste this one, ANN part. And if you want to like increase the number of neurons, you can do this, but again it will take time, right? The more you are giving the neurons, so the more it will take time, right? So let's just hide this one and keep this one as 100, and then followed by the final activation function, which is not the ReLU. This should be like the Softmax, okay? And here it should also the Softmax, right? We are by mistaken using this ReLU, right? You have to keep this Softmax, right? There might be chances the loss can be reduced and the accuracy will be improved, but the ANN will not give you up to that level of accuracy the way CNN gives you, right? So we are just using this convolution max pooling, convolution max pooling, convolution max pooling, convolution max pooling 4 times like this, and then we are flattening up your like the array. So we are using the flatten method. Then we are using the dense neural network. If you want to increase the neuron, you can use this. So let's just keep this as 500. Okay. So this is the activation function for the. Okay. Now the thing is that because we are not just using it for the first time now, so you don't need to give this input shape, right? This input shape is decided at the first step only, right? And we are giving the data set as like this. So this is the convolution that we are performing. Okay, candidate. Now let's just run this. This is the model that we have developed. Okay, this is the model. Now you know that you have to compile your model. So just simply call the model underscore CNN dot compile, and for the compilation part you have to decide the optimizer. Let's just use the Adam optimizer, and let's just copy the same with the previous one, the loss and the matrices as the accuracy, right? So let's just pass the same as sparse categorical cross entropy, matrices as accuracy. So we have compiled the model. Again, the spelling is incorrect. Model.compile. Now we have to fit our model. So let's just first fit this model for the 5 epochs to just understand the model is performing well or not, right? So extrain SC is like a scale data set and just perform this for 5 epochs to just check the model is performing well or not, right? So now we have fit this model. This is called the training part. Just wait for a while. The epoch 1 has started. It will take time, candidate. Why it will take time? Because we are performing convolution, max pooling, convolution, max pooling, convolution, max pooling, convolution, max pooling. Well, it is not recommended to use this level of convolution, right? Only two is enough, right? You can just hide all this one, right? Otherwise, it will take time. So just look at this. The loss, the starting loss, it is at 2, right? And but in the previous one, it was like close to some sort of like the 11, 12, and 13, right? So class, it will take time. Okay, it will take almost half an hour to particularly train this model for the 100 of the epochs, right? So we will keep this up to. Okay, we know that now the accuracy is improving. So why we are calling this like epoch for only 5 times? Let's just call this as 20. And what I'll do, I'll just try to minimize my model because the model will take so much amount of data. Okay, so 32, 32, and we are just using this 32, 32, then flattening up. Let me just comment out this. This is the model, compile model, and now just go with that one, right? So we have commented out this one, the 2 layers, right? You can use this one for your side, and the convolution and max pooling is done here. We are flattening the array, and we are just calling the dense neural network with the 100 of the neurons. And now just look at this. Still, we are getting the accuracy of like the 27%. Okay, now it will take some time to particularly train that model. Once we train this model, you know that you have to predict the value, and then you can particularly check whether the model is performing well or not, right? So let me know, candidate, in case of any doubt, class. Is there any doubt? In this way, you can create your model, right? You don't need to like learn all the set of code, right? You can take a reference. Okay. The thing that you have to understand, because nobody can particularly learn all the codes. You can take a reference. You just need to understand, okay, these are the things that you have to perform. You have to call your model. This is the convolution part. This is the max pooling part. This is the use of activation functions. Why we are using the padding. Okay, let me just show you. While the model is training now, let me just show you some facts. Why we are using padding here. Okay, suppose we have this image here, right? Suppose the image is here like this one. Let me just then directly call one images, right? It will consume your RAM, right? So your laptop should be highly configured, and you can, although you are using Google Colab now, but the impact is directly on the RAM, right? So let me just reduce the size of this and just make it to 14, right? 15. Perfect. Now just look at this candidate. This is the image, right? Now, if we are particularly filtering out the feature based on the kernel is something like this. Okay, this is the kernel filter. So if we are particularly moving up this one now, so the contribution of the pixel is limited, right? Just look at the corner pixels, right? The corner pixels are not contributing much because it will be counted only one times. Okay, during one iteration, the corner pixel will be counted, right? So what we are doing, we are just increasing the padding by some random pixels. So what you can do, instead of particularly calling your like raw image na, so you will do something like this. Let's just call this one. You will cut out your images and you will paste the image something like this. Let me just cut this again. Okay, and you will give the padding size something like this. Okay, this is the image candidate, right? This is the image, and what you will do, you will increase the padding size just like this. You will give the boundary as like this one. Okay, and instead of calling the raw image now, you are just calling the padding value, right? And you will fill out the value with set of colors, right? You are just increasing, and the color that we are giving is not the random color. We are just calling the boundary colors only, right? Whatever the boundary color. If it is green, you can just call the green color, right? And it is not the random one. Again, it will be like decided by the corner pixels, right? So now if you just call this, so just a look at this. With the help of this only, na, the contribution of pixel corner pixel will be counted as multiple times, right? So if you just starting from here now, let me just change the pixel like this. Okay, now just look at this. The contribution of pixel increase, right? During this iteration, it will be counted as one. Now just go to one step down, it will be again counted, right? So you are not ignoring the corner pixels, right? You are just giving the preference to the corner pixels as well. That is called the padding concept, right? So interviewer generally asks you this set of concept in the CNN problem, right? Now just look at this. At just 20th epoch, now we are able to attain an accuracy of 70%. So you can just, instead of 20 epochs, you can train your model up to 10 epochs only, right? And we are also reducing the loss so much, right? Now just so this is the like concept that can be asked in the interview as well. Now there is one more important concept that is called the data synthesization technique, and this is like you have to generate your images. So you have this image, you have this image, and you will create another images with the help of given images, and that is called image augmentation technique. Okay, this is again asked in the interview. So what is image augmentation technique? You have one image and you will create another image with the help of a given images, and this is called the image augmentation technique. You are just particularly doing some random flips, you are increasing some brightness, you are particularly changing some pixels, because there might be chances na, if the user can particularly trick the increase the brightness of the any of the pixels, so the pixel value will got changed and the model cannot detect the given features also, right? So you are particularly performing the data augmentation technique. Data augmentation is like you will get one input data, but parallelly you will create multiple data of the given data. That is called augmentation. Okay, and in this augmentation you will do some random flips with your data. You are flipping your like a butterfly, you are particularly rotating this one, because if your model is only trained with the correct data na, so it will not particularly predict the given data set. This could be the problem. Okay, if you are just giving this correct image of the dog, and if the model is predicting, okay, this is a dog, now what about this image? Okay, the model should also predict this as a dog image na. This one is also a dog image. So you are just synthesizing, you are generating the data of the given data set, and that technique is called the augmentation technique. I hope everyone is clear with that, right? Plus, any doubt with this topic? What is data augmentation in deep learning? So data augmentation is deep learning, or like in the CNN, is like generating multiple images based on the given sample of images, and you will do some random flips. You will perform some set of like silent edges. You will increase the brightness. You will decrease the saturation. You are some like you are applying some set of formatting over the images, right? So that all these images can also be participated in the input features, and so that it can be used for the model training as well, right? This is the main purpose of this kind of training, right? Now just look at this. Now you can imagine the level of complexities, or like the level of computational power is required to particularly train your model. We have only like this 60,000 of the images with the pixel size of 32 by 32 by 3. And just look at the complexities, right? Our RAM is costing us, like our RAM is costing so much. Why? Because the model taking so much of time to train that model. Okay, and we haven't checked the model parameters, right? We can check the model parameters as well with the help of model.summary. Okay, and during the like at the seventh iteration of the given 20th epoch, we are getting the accuracy of 76%. Now once the model is trained, let me give you the next task. You know that you can particularly predict the model. So how you can do this? Let me just write the code. You can run this one. Model underscore CNN dot predict. You can simply give your X data set, and this will give you what? This will give you the HCA. This will give you the Y predicted value. You can just simply store this Y inside Y predicted. Okay, this is the Y predicted. Okay, now let's just try to predict the Y predict with the help of ANN and CNN as well. Okay, there is no use of using the ANN because the model is not trained well, right? So let's just directly use the CNN part, right? Now, once you got this as Y predicted, so what you can do, you can just simply check your like the final prediction. Okay, so now let's just click on this code because the model is not particularly trained yet. So we are not running this code. Now, once we got the y predicted value, so y predicted will be in a form of 10 different classes. Okay. We will get the 10 different classes for the each classes, right? We have to like particularly check those value. So you can flatten, you can keep this as flatten, right? To just compare with your Y dataset. Now you can draw the confusion matrix and all, and it will try to predict the the multiple values. So you can just store this inside CNN. And now just look at this image again, candidate. It will not only give you the 0.7 probability to the panda, it will give you the probability for the red panda as well and for the raccoon as well. In the same way, it will not only give you the probability for the individual class, it will give you the probability for the 10 of the classes. You have to find the maximum probability, and that will be considered as the final prediction, right? So here what you can do in this ypred CNN, this y predicted CNN, you can run your list comprehensor, go to this for I in y predicted CNN, okay, and you can just simply, you have one method that is called np.argmax, okay. Argmax is like, it will give you the index value of the maximum value of the given array. This is called the argmax, and this is the final ypred you can just use, okay. So let me just write this as final ypred, okay. Now you have ypred, which generally gives you the probability of the each classes. Now you have the final ypred, and what you can do, you can simply particularly compare your model with the actual value, and you can simply check with the confusion matrix or like with the help of a classification report as well. So let's just try to particularly compare with help of confusion matrix. So you can call the confusion matrix. I think we haven't called the confusion matrix. No issue. You can call the confusion matrix, candidate. Okay. Let me just write all these arrow these are the homeworks. What you can do, you can just call the confusion matrix. Okay. And you can just run the classification report. Okay. And then in the next class we will already like dump this model. Okay, I'll dump this model. You know that how to dump the model with the help of pickle module. Okay, once I dump this model, so I'll directly call this model and to predict some values. Okay, so we will complete this in the next class because you know that it will take time, right? Just only 10 epochs we have completed. Okay, so I'll just stop this code. In the next class, I'll already run this code. I'll save my model, and with the help of that model, I'll try to predict that one, because this will take time. In the next upcoming whatever model that we are particularly performing, this will like almost takes more than half an hour to particularly train that model, right? So I'll try to already run that model, and then you can particularly understand the concept behind this, and then we can probably predict the values, right? Okay, so in this way we have predicted this value, and once we have predicted the values, then you can randomly give any of the images and you can predict the values as well. Okay, candidate. So just let me know in case of any doubt. There is no particularly meaning to wait for this to complete, because it will again takes 15 or like 20 of the minutes to get it done, right? So let's just complete this. I'll just simply stop this one right now. I'll complete this and let's just particularly connect tomorrow, and then you can use this model for the prediction kind of thing, right? Then I'll try to build the website, and where user can give the images, and that images can be classified with the different classes with the help of models that we have built, right? So let me know in case of any doubt. You can connect me, and let me just share this notebook with you so that you can run this, right? And you can do the practice from your side and just read more about this, what exactly this CIFAR dataset is, and just try to complete this model from your side. Well, the main part is already completed. You just have to take the reference of this notebook, and then you can, okay, sir, can you send the collab link? Okay, you can just check this one, right? Because the model training will take time, right? So you can just take a reference of this. I have already shared this one. Okay, I'll also upload this one over the GitHub link. Then you can download this one and you can practice it from your side, right? And this is very popular data set, candidate. Again, I will repeat, right? So here you are getting these 10 classes of 60,000 of the images, right? Where you can simply give the images and it will try to predict or to classify the images based on the given classes. These are the popular data set, right? So let's just close this session for now, and you can just have a reference of this notebook, and let's just connect tomorrow. Okay, candidate? So wish you all the best. Let's connect tomorrow. Bye-bye.